say is that I want to talk about this word here. Have you used this word in your educational career before? Inference. What does it mean? Yeah. Okay. You guys are so smart. That's excellent. Okay. And the whole second half of this class is called inference, which means that you're getting a sample and you're using that to estimate something about the population. That's the whole point of statistics. Otherwise, if we knew everything, we wouldn't need to estimate. So when you see this word, it's educated guess, like hypothesis. You guys had it, you guys were right on. Okay. When we do FRQs on the AP exam, there's guaranteed to be one of them at least, maybe two, maybe three that are inference FRQs. You're going to want those because those are the ones that we just did like recently. So you'll know how to do those really well. You don't know how to do it now, but you will. And those will end up being the easy ones. The ones you're probably not going to love are going to be just in past experience have been like the binomial and geometric and the tree diagrams. But anyway, okay. When you do an FRQ, you need to have four things. And we do this little outline. The book gives us this little outline to help us remember the four things. You need to do state, plan, do, and then conclude down here. The state is state the parameter you want to estimate and confidence level. In this case, we're just going to talk about P. So I would state what I want P to be in context and the confidence level. Can you guys please focus? They will always have to give you the confidence level in the problem. So every problem will have a confidence level in it. The plan, you're going to say what you're doing and check the conditions. There are three conditions. You already know them. We just need to put them in, like, write them down. And then do step is actually the calculation part. So can you guys grab your yellow sheets out of your bag, whatever, notebooks, whatever. And what I want to do is I want to relate the calculations to the yellow sheet as much as humanly possible so that you know where to look. Okay, so we're talking about confidence intervals. So we want to look at this thing that says confidence interval, and you want statistic plus or minus critical value times standard error of statistic. Okay, so I just wrote this down straight off my yellow sheet, and my goal is to figure out what numbers to put in these spots. Since we are working with P, our sample statistic will be P hat. So P is the true proportion. P hat is from your sample. Does that make sense to you guys? Okay, so the statistic is going to be P hat. Plus or minus. Critical value is the number of standard deviations out on either side, which is Z, except we do Z star because we want absolute value. If you were not here yesterday, that's going to sound like I'm speaking a different language. But if you watch yesterday's video, it'll make more sense. I promise. Okay, anyway, Z star times, okay, and then standard error of statistic. Okay, so this is the part where I wanted to point you in the right spot. Okay, so you're here, P hat, plus or minus, V star, and then flip to the back of this page and find the standard error of statistic that has to do with P and P hat. This one. Do you guys see it? So this is saying for one population, P hat, the mean of the sampling distribution is P, standard deviation of the sampling distribution is this, standard error of the statistic is this. Do you guys see it? Okay, so you're going to go times square root p hat 1 minus p hat over n. Okay, and then your conclude is going to be the sentence where we interpret the confidence interval. And this is the reason why I don't think that we need to practice interpreting the confidence interval, because you're going to write that sentence at the end of every FRQ. The other one that I was talking about, the over many, many thing, we don't do that one as often. So that's the one you're going to want to like look at every couple of days. Does anybody remember it? Over many, many? No. Random samples of size n equals. Yeah.
Percent confidence for each one. Something confident.
Yeah, I was pretty darn good for like 3 days in the chapter. I'm impressed. Okay. All right, so just write this, guys, this little bit here. You don't have to write this business yet. Just write the trash get ball part. Each one of your groups is going to need some supply. You're going to need a ball. We're going to have to take this piece of paper and crinkle up into it. You're going to need a trash kit. And you're going to need a line to throw from. Okay, I do not care where your line is. We're not going to be measuring in this class. You just need to all agree in your group on where that line is going to go. Okay, what I suggest is if you have a group of 4, just set up your trash kit with your line. Each person does 25 and have somebody sitting near the trash kit so that they can throw it back to you to make it quick. Does that make sense? Each group needs to have a total of 100 shots, not 100 shots each, a total of 100 shots. You guys are gonna have to do 33, 33, and 34. Does that make sense? Okay, and you guys are gonna have to keep track of how many went in. And if you'd like to correct each other about being good or bad at it, that's totally fine with me. Okay, so you just have to keep track of how many go in. We need 100 total. You guys do like 20 each back there. Does that make sense? Okay, so you need a line, you need a trash kit, and a ball. I'll bring the balls around. Someone can crinkle. It's your ball. You gotta crumple it up. I picked orange on purpose so they would look like basketball. Okay, grab the line, get the line. Come over here. Send someone over this direction again. Oh, yeah. Yes, that's your start. Yes, just don't be obnoxious. That's place paper. You guys kind of. Oh my goodness. So you're gonna do your I don't know how much she does. Yeah. Yeah, no, you can. It don't take too long. 100 total. guys just have to all agree. It's all about agreeing. And I wore hot shoes. I shouldn't have worn hot shoes today. I know, they are.
I've only used like two.
Okay. Okay, first thing I need you guys to do is just somewhere write down whatever your percentage was for your the total for the group. So trash can. Oh, it's right there. Thank you, Audie. Thank you. Okay. So you guys just have a decimal, 2-digit decimal. Okay. Now, I'm gonna write a number over here that would be, I'm just gonna make one up. You're going to have your actual group shots over 100 made equals 0 point whatever, whatever. But because we're gonna do a math problem, I wanna have a number to use. 34?
I thought you were 35. 38.
I'm gonna do 7. I think that would be what I would get out of 100 shots. That's me. That's Mrs. Talbot's group. Don't tease me. I am a math person, okay? All right, now, I went with 7 because I'm not an athletic individual, and I'm assuming that's about how many I would make out of 100. Okay, and anyway, over here, I'm going to put 0.07. All right, I'm going to use this number. You guys don't use this number, use the number that you have for your group. Does that make sense?
Yeah.
Okay. State. 95%, and I'm telling you we're doing 95%. The problem will have to tell you, I'm telling you right now, 95% confidence interval. For P equals true proportion of shots made by my group. Okay, now I sort of did this wrong, to be honest. We should do the statement plan before you do the sample, technically. Don't you think you should probably do the plan before you do something? And that would be a good idea. Okay, but okay, I want to make sure that you understand what this is saying. So we're going to find a list of plausible values, a range of plausible values for the true proportion of the shots made by your group if you were to keep shooting forever. The true, so you're estimating what the real true proportion of shots made by your group would be if you shot forever. Does that make sense? Okay, so we're using our sample to estimate what your theoretical shot percentage is. Okay, so 4-step process, FRQ, state the parameter you want to estimate and confidence level. I stated the parameter I wanted to estimate and the confidence level. Okay, now plan. Identify the correct inference method and check conditions. Okay, the inference method we're using in this one is called a one sample Z interval for P. I underlined it at the top of the page if you want to look up there. And that feels weird right now, but it won't later, I promise. Okay, and each of these has 3 conditions. And you've done all of them before. Okay, now, random. This one we're gonna have to bend a little bit. We're gonna have to ignore the fact that you might have gotten better or worse over time. We're gonna have to ignore the fact that you're all separate people. We're gonna have to ignore a lot of friction in the air and weird, wind, stuff like that. So we're going to say, assume 100 shots is a random sample of all shots forever. Check. Most of the time, probably like I would say 90% of the time, you're just going to look for the word random in the math problem that you're doing. But we have to state that it's random. So we don't know, so we're just going to assume it. Isn't that great? And move on with life. Okay, now 10%. You guys have done this one before. N equals 100. I forgot the 10%. It's true that it's less than all shots forever, but it's also less than 10% of all shots forever, because all shots forever is infinite shots. Okay, large count. Does anybody remember what that one is? NP greater than or equal to 10. Yep. And 1 minus P greater than or equal to 10. Okay. Now let's be really smart about this. What is N in this problem? Let's 100. And what is my P? I don't know, so I'm going to estimate using my P hat. Nope, don't write this. What number did I get? Where is this 7 located in my math already? Yeah, so I don't really need to do N times P in this case. I can just say, oh, this is my successes, because N times P ends up being my successes. You can do this math if you like, but you're going to feel silly because the number is right there. Oh gosh, I violated this condition. Well, hopefully I should have picked something big. It's fine. Okay. And does it make sense that this has to be the rest of them then? Okay, yeah. So this is what we call successes, and this is what we call failures. We're just gonna put a check mark there because I'm hoping that you guys all have more than 10. Do you all have more than 10? Okay, few. What? Well,
Number 35.
I should have just done 11. Do you think I could make 11 out of 100? I don't think I could.
That's what we're doing right now. Miss Talbot's like 100 shots right now.
No, I just get embarrassed to probably cry. You guys don't need to erase anything because you're not supposed to be using my numbers anyway. Really quick, you guys used your own numbers here, correct? Okay, do. I wouldn't even be able to do a confidence interval for mine. I did so terrible. Okay, anyway. Okay, so over here, I'm going to say, okay, P hat is 0.11. You guys write yours. Don't write mine. write yours, please. Okay, and then Z star. I want you guys to go on your calculator, see if you can remember how to find Z star. You might need to look back in your notebook. Mm-hmm. Yeah, if you're lucky, it's still in your calculator from your homework. That was from my stuff. You guys should use your own number. I just need something to plug in there. Everyone should have the same Z star though. It should be 1.96. Did you not get 1.96? Oh, look, it's still in there. Okay, if you were absent yesterday, the star means absolute value. So I got negative 1.96 there, so I absolute valued it to positive 1. Okay, anyway. Okay, so now we fill this stuff in. You guys use your number, not mine. 0.11 plus or minus 96. You're supposed to use your number here. Here, I'll highlight it for you. Look at, okay,
On seven, these are numbering.
these right here, you should be using the number from your group, not 0.11. Yes, everyone should have 1.96 though. Excellent question. Okay, so now calculate. This is way easier than quadratic formula. Yeah, honey. I don't think you should get a negative number. Okay.
Yeah, I put your number on it.
Oh,
Okay.
yeah. Those highlighted numbers, you want to use your number, not mine. Okay, sorry about that. I think I just made it more confusing. It should have just left it like a blank. I try to help, but maybe. Do you guys all see how I got the low and the high? For the plus or minus there?
Nope, I think.
Okay,
Public access,
oh, yeah, yeah. Bloody nose. Jamie, are you okay?
Yeah, I'm good now, I got it.
Okay, all right. Last thing, sentence. We are 95% confident. Confident. I need to write the word confident. Full FRQ for one sample, one problem. But let's make sure that we know what we did there. So we found a plausible range of values for the true proportion that would be shot by your group if you shot forever. And it was random and all of those things. By only getting one sample, which is great. So you're saying, okay, I got this one piece of data, this one sample I took. And just from that one sample, I can pretty much say that I'm somewhere between here and here. So I got a sample from Mrs. Talbot throwing the trash ball. She made it in 11 times. So we're pretty sure that for the rest of her life, if she shot the trash ball, she'd make it in there between 5 and 17%. I shouldn't laugh at that. That's funny. Okay. So we have one more thing to do and then we're done. It's because it's dry. It's, yeah, 66. I shouldn't have worn the hot shoes. It was dumb. Stupid, stupid, stupid. You should have come just like 15 minutes ago. We were playing a game. Now the fun time's over.
Trying to find the convenient cozy for you,
That's perfect.
actually.
Yeah, but they told me that I don't have to wash them till Friday.
Yeah.
Mhm.
Oh, I brought my greens and from.
Maybe I know.
Okay, guys, all right, so. Yes. Miss Morgan, do you approve of the attire on that sock baby?
What it looks like point size in terms of.
Ooh.
Let me give it express.
I had to go visit Mr. Haig because Aiden Chen's still not sure if it's an abandonment or an abduction issue with this baby. He was told by Haig to find better friends. See how it works out.
Keep me posted. Okay, anyway, all right, so you're doing an FRQ and I want to show you how to keep rolling in case there's some kind of issue. Okay, so most of the time you'll meet all three conditions, no problem. So for the random, if random is not stated in the problem, and doing an FRQ, very different from doing an MCQ. If random is not stated in the problem, and doing an FRQ, right, assume, and keep going. Okay, just what we just did in the previous one is a perfect example of it. It didn't say random, didn't say random anywhere. We kind of have, I don't know about you, but I'm a little suspect about whether or not those shots were random. Because you could get better overtime or worse overtime, have people not standing on the line properly and wind and friction and yeah, all kinds of issues, right? But you're doing an FRQ. When you take the AP test, the FRQ space they leave you is almost an entire page. That would not be the time to go random condition not met and leave the whole page blank. Okay, we don't do that. You have to do the problem. So if it doesn't say random, you say assume random sample, blah, 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 like we did in the previous one. Just move on with your life. You know, you might have a little bit of a moment like, that doesn't seem right, but you just move on with your life. Do the problem, don't abandon it. Now, if you're doing an MCQ, chances are the MCQ would say something like what condition is being violated. Then it would be the random condition because the problem didn't say random. Do you see the difference between those two things? Okay, 10% condition. If the 10% condition is violated, which I think mine, oh no, it was fine for this one. Standard error, error, standard error. Standard error will be larger than it would be if it was met. So if the condition was met, you have the regular standard error formula. If the condition is not met, the standard error will be larger, which means two things. The confidence interval would be wider. And you would capture the true proportion more than your confidence level. So if you said 95%, would actually be catching it more than 95%. This is kind of like being really conservative and saying, well, like being like Garfield and being like, well, I want to be really, really sure. So I'm going to say -40 to 200, which is a huge range. Doesn't really like give you any valuable information. Okay. Opposite with large counts. Confidence intervals would be too narrow. And you would capture the true proportion less than your confidence level, which is a much bigger problem. Okay, last thing. Does it always make sense to calculate a confidence interval? The answer is no, and the reason is because I wouldn't ask this question if it wasn't a no answer. No, but the reason is because no. No. If the study is created poorly, meaning that there's wild bias in the question that's being asked, or voluntary response sample, or a convenience sample, if there's some kind of really huge flaw in the design, the confidence interval isn't going to mean anything. To be honest with you, our confidence interval from our test result probably doesn't really mean anything, right? Because there are a lot of variables there. Like all the things I mentioned. Getting better over time and apparently getting worse over time was one of them. I thought some of you guys switch up your technique in the middle. Oh. Well, no, I'm not just saying, like, you know, if you're doing an actual research study, you wouldn't want somebody to do that. So anyway, doesn't always make sense. And I'm done. And you have 20 minutes to do whatever you need to do, which is take a nap, I think. Yes, yes. I have no idea how you can drink the school water, but sure.